Unraveling the Cosmic Code, from Digital Physics to Quantum Teleportation. April 9, 2024. Simulated Reality, Digital Genome, Quantum Frontiers. Yes, I may be considered unconventional in my thinking. People also call it crazy. But I'm not alone in exploring these ideas. Leading scientists, physicists, and researchers are increasingly investigating the possibility that our reality is a simulation or matrix. Even though the majority of the scientific community still regards these concepts with skepticism, the notion that each individual possesses a unique digital code, which could be replicated for various purposes, is a captivating and thought-provoking idea with profound implications. When viewed through this lens, the concept that a person's entire life is being recorded within their genetic makeup, and that we are striving to bring the memories and experiences of past lives to our future selves, takes on a new and profound significance. This idea suggests that our struggles and experiences are not confined to a single lifetime, but are part of a grander tapestry, woven across multiple existences. Our lives, with all their joys, sorrows, triumphs, and tribulations, are encoded within our genetic makeup, forming a unique signature that defines our essence. This signature, or digital code, could be seen as a repository of our memories, experiences, and the very essence of our being. The future self, which we might call God, the universe, or any other grand concept, could be the culmination of all these experiences. A being that has achieved a level of consciousness and understanding far beyond our current comprehension. This future self may be envisioned as a young blue star, born from the collapse of the universe after it has exceeded its energy capacity, symbolizing a cycle of destruction and rebirth, with the potential for the emergence of a new, enlightened form of existence. If we assume that this particular signature of a man may be replicated, it opens up a world of possibilities in various fields, including time travel, teleportation, and medicine. In the realm of time travel, the ability to replicate an individual's digital code could allow for the exploration of past lives and the potential to influence the course of history. By accessing the genetic records of our ancestors, we may be able to gain insights into their experiences, learn from their mistakes, and build upon their wisdom. In the field of teleportation, the replication of an individual's digital code could enable the instantaneous transmission of a person's essence across vast distances. This could revolutionize transportation, allowing for the seamless movement of individuals across the globe, or even to other planets, without the need for physical travel. It could also have profound implications for space exploration, enabling us to send digital copies of ourselves to distant worlds and expand our understanding of the universe. In medicine, the ability to replicate an individual's digital code could lead to personalized treatments and therapies tailored to each person's unique genetic makeup. By understanding the specific genetic factors that contribute to health and disease, we may be able to develop targeted interventions that optimize well-being and longevity. Furthermore, the potential to access and modify an individual's genetic code could open up new avenues for treating genetic disorders and enhancing human capabilities. The idea that our lives are being recorded within the continuous genomes also highlights the importance of preserving and passing on our collective knowledge and experiences to future generations. By creating a simulation or matrix that encapsulates the collective wisdom of our species, we may be able to accelerate the development of those who are lagging behind, ensuring that they do not drag us all into extinction. This matrix could serve as a tool for enlightenment and progress, elevating the collective consciousness and steering humanity towards a brighter future. As we navigate the complexities of our existence and work towards creating this matrix, we must remain open to the possibility that our reality is more than what meets the eye. The challenges we face may be daunting, but by harnessing the power of information and using it to create a more comprehensive understanding of our reality, we may yet find the salvation we seek. The creation of a matrix that bridges the gap between the most advanced and the most retarded parts of humanity is a crucial step towards securing our future and unlocking our true potential as a species. The simulation hypothesis, introduced by Nick Bostrom in 2003, presents a fascinating proposition that our reality might be an advanced computer simulation created by a more advanced civilization. Are we living in a computer simulation? The Philosophical Quarterly, 53-211. This concept has sparked discussions across various disciplines, leading to a rich body of literature that explores its philosophical implications, technological feasibility, and implications on human understanding. Bostrom's seminal work laid the philosophical groundwork for considering our reality as potentially simulated, positing that advanced civilizations might generate simulations indistinguishable from reality. Bostrom, 2003. The Simulation Argument, Some Explanations, Analysis 69. However, Shreyansh Goyal critically examines Bostrom's probabilistic arguments, suggesting that the Bayesian analysis could justify skepticism towards the high probability assigned to us living in a simulation, thus challenging the inevitability of the hypothesis. Goyal, S. 2019. The Simulation Argument and Incompleteness of Information. J. White expands on Bostrom's argument, exploring the technological capabilities required for ancestor simulations and the ethical implications of such simulations for both creators and inhabitants. White, J. 2016. Simulation, Self-Extinction, and Philosophy in the Service of Human Civilization. David Kipping applies Bayesian reasoning to the simulation argument, suggesting that the actual probability of us living in a simulation is less than 50%. Ain't. A reinterpretation that introduces model uncertainty into the debate. Kipping, D. 202. 0. A Bayesian approach to the simulation argument. Popular Physics. M. Irkovy links the simulation hypothesis with existential risks posed by AI, arguing that acknowledging the possibility of living in a simulation could have implications for how we manage risks associated with advanced technologies. Irkovy, M. 201. 5. Linking simulation argument to the AI risk. Futures. Ravan Kumar's work on the mathematical foundations of the simulation hypothesis provides insights into the computational aspects and potential capabilities of such a simulated universe. Kumar, R. 2021. Mathematical Developments in the Simulation Hypothesis. Cosmology and Large-Scale Structure e-Journal. The simulation hypothesis remains a profound and provocative idea that bridges philosophy, technology, and ethics. While I tend to think that we are not a part of the simulation, I believe that a simulation is our very natural outcome. Until we converge the most retarded part of our civilization to catch up, it invites us to reconsider the nature of reality and our place within it. As research continues to evolve, the hypothesis provides fertile ground for interdisciplinary exploration, challenging us to confront the limitations of our understanding and the possibilities of our future. Digital physics, also known as digital ontology, posits a paradigm where the universe is fundamentally digital, composed of discrete units of information rather than continuous phenomena. This perspective suggests that at its core, the cosmos operates similarly to a computational system, governed by bits of information and rules akin to computer algorithms. One of the early and prominent advocates for this view is Edward Fredkin, whose work in the late 20th century laid foundational concepts for the digital philosophy. Fredkin, E. 1990. Digital Mechanics, an informational process based on reversible universal cellular automata. Physica, D. Nonlinear Phenomena. 45. Edward Fredkin's seminal paper, Digital Mechanics, an informational process based on reversible universal cellular automata, published in 1990 in Physica, D. Nonlinear Phenomena, argues for a universe conceptualized and operating as a vast computational entity. Fredkin posited that all physical phenomena could ultimately be modeled as information processing, with the universe itself functioning like a computer executing a program. This radical idea shifted the discussion from viewing the universe in terms of matter and energy to one of information and computation. Cellular automata, as discussed in the Scholarpedia article by Hector Zanil and Gennaro J. Martinez, 2024, are deterministic rewriting dynamical systems that evolve in discrete time and discrete space, usually a grid. They consist of a local grid of cells that are synchronously updated across the grid, according to a global timescale, and a global recursive rule governing the evolution of the state of each cell as a function of the state of neighboring cells. Cellular automata have been studied extensively in the context of fluid dynamics biological systems. In the quest for a universal constructor, a computational model that could describe itself and self-reproduce, Stephen Wolfram's systematic study of cellular automata models, particularly elementary cellular automata, ECA, in the mid to 1980s contributed significantly to the expansion and professionalization of the field. Wolfram's discoveries, such as the ability of even the simplest CA models to generate high-quality statistical randomness, challenged the prevailing notions of complexity and chaos in dynamical systems. Cellular automata have found applications in various fields, including traffic modeling, e.g., the Nagel-Schreckenberg model, social dynamics, epidemics, and other complex phenomena. They've also been used to simulate physical phenomena such as gas and fluid dynamics, as they can be designed to obey the laws of thermodynamics through reversible rules. In the realm of computation, cellular automata have been studied extensively, with significant contributions made in areas such as automata dynamics, language recognition, reachability, decidability, and computational complexity. The connections between cellular automata and Turing universal computability have deepened our understanding of the fundamental principles of computation and the behavior of complex systems. Wolfram's principles of computational reproducibility and equivalence have further pushed the boundaries of our understanding of cellular automata and their implications for the nature of reality. Computational irreducibility suggests that most questions regarding long and even short-range reachability involving CA evolutions are, in a sense, unsolvable without having to simulate the CA step by step. Computational equivalence establishes that rules capable of non-trivial behavior are equally powerful and capable of Turing universality. The classification of cellular automata based on their behavior, introduced by Wolfram, has provided insights into the types of dynamics that cellular automata can exhibit. From simple and predictable to chaotic and complex, various approaches and proposals have been made to formalize or develop alternative classifications based on order parameters such as information theoretic measures, power spectral analysis, topological properties, lossless compression, Lyapunov exponents, algorithmic complexity, mean field theory, and morphological diversity. Subclasses of cellular automata, such as totalistic, stochastic, continuous spatial, non-uniform, lattice gas, and those defined on non-Euclidean geometries or non-square lattices, have further expanded the scope and potential applications of cellular automata in modeling and understanding complex systems. The implications of digital physics extend far beyond the realms of physics and computer science, posing profound questions for philosophy, ethics, and our understanding of reality. If the universe is fundamentally digital, several philosophical questions arise regarding determinism, free will, and the nature of cons. Additionally, this perspective has ramifications for technological pursuits such as quantum computing and the development of artificial intelligence, suggesting pathways to mimicking the computational processes of the universe. Digital physics naturally dovetails with the simulation hypothesis, another provocative idea suggesting that our reality might be an advanced computer simulation. Both concepts challenge traditional notions of reality and physics, proposing that at a fundamental level, our universe operates more like a computer than a classical physical system. The simulation hypothesis, popularized by philosopher Nick Bostrom, further extends the digital ontology perspective by questioning the authenticity of our perceived reality. Bostrom, N. 2003. Are You Living in a Computer Simulation? The Philosophical Quarterly, 53, 211. As we advance in our understanding of quantum mechanics, computing, and information theory, the principles of digital physics may offer new insights into the fabric of the universe. Researchers continue to explore the digital nature of reality, examining quantum bits, qubits, and the informational underpinnings of physical laws. The ongoing dialogue between scientists and philosophers in this field is crucial for unraveling the digital tapestry of the cosmos and understanding our place within it. Digital physics presents a groundbreaking perspective on the fundamental nature of the universe, suggesting a shift from a materialistic to an informational paradigm. Edward Fredkin's pioneering work has opened a Pandora's box of philosophical and scientific inquiries, challenging us to rethink the essence of reality. As we delve deeper into the computational universe, the fusion of information theory, physics, and computer science promises to unveil new realms of knowledge, forever altering our conception of the cosmos. This exploration into digital physics and its implications invites us to reconsider not just the universe's workings, but our very understanding of what it means to exist within this vast computational network. The journey through digital ontology is only beginning, with each discovery bringing us closer to answering the age-old question, what is the universe made of? The holographic principle represents one of the most fascinating and revolutionary ideas in theoretical physics, suggesting that the entirety of the universe can be described by information encoded on a two-dimensional surface. This principle challenges our conventional understanding of dimensional space and the fabric of reality itself. Initiated by Gerard T. Hooft and further elaborated by Leonard Susskind in the mid-1990s, the holographic principle has become a pivotal concept in the quest to unify quantum mechanics with general relativity. The concept was first brought to light by Gerard T. Hooft, laying the groundwork for what would become a radical shift in understanding the universe's structure. Leonard Susskind's seminal paper, The World as a Hologram, published in 1995 in the Journal of Mathematical Physics, delves into the intricacies of this principle, offering mathematical foundations and theoretical frameworks to support the holographic view of the universe. Susskind, L. 1995, The World as a Hologram. Journal of Mathematical Physics 3611. At its core, the holographic principle posits that the information which constitutes our 3D reality is actually encoded on a 2D surface, similar to a hologram. This suggests that, contrary to our everyday experiences, the universe fundamentally operates and exists in 2 dimensions, with the perception of 3 dimensions being an emergent property of the underlying holographic encoding. This idea introduces a profound implication that our perceived reality is essentially a projection of this 2-dimensional information. The holographic principle has significant implications for the unification of quantum mechanics and general relativity, 2 pillars of modern physics that have historically been at odds. By suggesting a new way of conceptualizing space-time and gravitational phenomena, the principle offers a potential pathway to a quantum theory of gravity, one of the holy grails of theoretical physics. Moreover, this principle has ramifications beyond physics, touching upon philosophical questions about the nature of reality, perception, and the limits of human understanding. It challenges the very notions of space, time, and material existence, suggesting that our deepest intuitions about the universe may need to be reconsidered. Since its inception, the holographic principle has inspired a vast amount of research, seeking to test its predictions and apply its frameworks to solve long-standing puzzles in physics. One area of focus has been the study of black holes, where holographic ideas have provided new insights into their properties and the information paradox. The principle also plays a crucial role in string theory and attempts to formulate a consistent theory of quantum gravity. The holographic principle represents a paradigm shift in our understanding of the universe's fundamental nature. By suggesting that our 3-dimensional experience of the universe may be derived from 2-dimensional information, it opens up new avenues for understanding the cosmos's deepest mysteries. Gerard Hooft and Leonard Susskind's contributions have laid the foundation for a field of study that bridges theoretical physics, quantum mechanics, and philosophical inquiry, promising to reshape our reality concept in profound ways. As research into the holographic principle continues to evolve, it stands as a testament to the power of theoretical physics to challenge and expand our understanding of the universe. The journey into the holographic universe is only just beginning, with each discovery bringing us closer to deciphering the cosmos's true nature. Exploring the holographic principle not only invites us to reconsider the structure of the universe, but also challenges us to question the very nature of reality itself. As we delve deeper into this holographic universe, the boundaries of science, philosophy, and knowledge continue to expand, offering new perspectives on the cosmos and our place within it. Quantum teleportation stands as one of the most intriguing and promising phenomena in the realm of quantum physics, challenging conventional notions of space, time, and the very fabric of information transfer. This process, which has been experimentally validated, involves the transmission of a particle's quantum state to another particle, effectively allowing for the teleportation of information. It's a concept that straddles the line between the science fiction allure of teleportation and the tangible, albeit complex, reality of quantum mechanics. The foundational work of Bennett C. H. Brassard, G. Carpo C. Jaza R. Perez A. and Wooders, W.K. in their 1993 paper, Teleporting an Unknown Quantum State via Dual Classical and Einstein-Podolsky-Rosen Channels, laid the groundwork for what would become a significant area of research within quantum physics. Their work detailed the theoretical framework and experimental foundation for quantum teleportation, demonstrating that it's possible to transfer the quantum state of a particle across space without moving the particle itself. Bennett, C.H., Brassard, G. Carpo, C. Jaza, R. Perez, A. Andamp, Wooders, W.K., 1993. Teleporting an unknown quantum state via dual classical and Einstein-Podolsky-Rosen channels. Physical Review Letters, 7013. Quantum teleportation is predicated on the principles of quantum entanglement, where two particles become interconnected in such a way that the state of one, no matter the distance separating them, directly affects the state of the other. This phenomenon, often referred to as spooky action at a distance by Einstein, enables the teleportation of quantum information. It's crucial to distinguish this from the science fiction concept of teleporting matter. Quantum teleportation deals exclusively with the transmission of information regarding a particle's state, not the particle itself. The experimental realization of quantum teleportation has profound implications for the future of information technology, particularly in the realms of quantum computing and quantum communication. By enabling secure, instant transmission of information across vast distances without the risk of interception, a principle known as quantum cryptography, quantum teleportation could revolutionize how data is shared and stored. Moreover, it provides a deeper understanding of the fundamental principles of quantum mechanics and entanglement. As research into quantum teleportation progresses, scientists and engineers are exploring its potential applications in developing a global quantum internet, which would offer unprecedented levels of security and speed in data transmission. Additionally, quantum teleportation could play a crucial role in the construction of quantum computers, machines capable of solving problems far beyond the reach of today's classical computers. Quantum teleportation remains one of the most fascinating aspects of quantum physics, offering a glimpse into the potential future of information transfer and the ongoing quest to understand the quantum universe. The foundational work of Bennett and others has opened the door to a world where information can traverse space in ways previously thought impossible, marking a significant leap forward in the intersection of quantum mechanics, information theory, and technology. As we continue to unravel the mysteries of quantum teleportation, it promises to not only deepen our understanding of the quantum world, but also pave the way for advancements in technology that could redefine our relationship with information and communication. Quantum teleportation illustrates the remarkable potential of quantum physics to redefine the possibilities of information transfer and encryption. As we delve deeper into this quantum realm, the boundaries of what is possible continue to expand, heralding a new era of communication and computational capabilities. Ultimately, whether we are living in a simulation or not, the key to our survival and advancement lies in our ability to embrace the concept of a matrix that encapsulates our collective wisdom and experiences. By doing so, we open ourselves up to new possibilities for growth, transformation, and the exploration of the very essence of our existence. As we continue to navigate the complexities of our reality and work towards a greater understanding of our place in the universe, we may yet uncover the true nature of our existence and the profound implications of our interconnectedness across time and space. The ideas presented in this article, from the concept of a simulated reality and the unique digital code of each individual to the principles of digital physics, the holographic universe, and quantum teleportation, collectively paint a picture of a reality far more complex and interconnected than we might have previously imagined. These concepts challenge our traditional notions of space, time, matter, and information, inviting us to reconsider the very fabric of our existence. As we continue to explore these ideas and push the boundaries of our understanding, we may find ourselves on the cusp of a profound transformation in how we perceive ourselves and our place in the universe. The potential implications for fields as diverse as philosophy, technology, medicine, and space exploration are vast and far-reaching, promising to reshape our world in ways we can scarcely imagine. Yet amidst the excitement and promise of these ideas, we must also remain mindful of the challenges and responsibilities they entail. The creation of a matrix that bridges the gap between the most advanced and the most retarded parts of humanity is a noble goal, but one that requires great wisdom, compassion, and foresight. We must strive to ensure that the benefits of these advancements are shared equitably, and that they are used to uplift and empower all of humanity, not just a select few. Ultimately, the journey towards understanding the true nature of our reality and our place within it is one that will require the collective efforts of scientists, philosophers, and visionaries from all walks of life. It is a journey that will test the limits of our knowledge, our creativity, and our resolve. But it is also a journey that holds the promise of unlocking the greatest mysteries of our existence and propelling us towards a future of unimaginable possibilities. As we stand on the precipice of this new frontier, let us approach it with a spirit of curiosity, humility, and determination. Let us be willing to question our assumptions, to embrace new ideas, and to work together towards a common goal of understanding and betterment. For it is only by harnessing the power of our collective wisdom and experiences that we may hope to navigate the complexities of our reality and secure a brighter future for ourselves and for generations to come. In conclusion, the ideas presented in this article, while speculative and far-reaching, offer a tantalizing glimpse into the potential future of our understanding of reality and our place within it. From the concept of a simulated universe and the unique digital signature of each individual to the principles of digital physics, the holographic nature of reality, and the mind-bending possibilities of quantum teleportation, these ideas challenge us to expand our horizons and embrace a more expansive view of what is possible. As we continue to explore these concepts and push the boundaries of our knowledge, we may find ourselves on the cusp of a profound transformation in how we perceive ourselves and our world. The implications for fields as diverse as philosophy, technology, medicine, and space exploration are vast and far-reaching, holding the promise of reshaping our reality in ways we can scarcely imagine. Yet, amidst the excitement and promise of these ideas, we must also remain mindful of the challenges and responsibilities they entail. The creation of a matrix that bridges the gap between the most advanced and the most retarded parts of humanity is a noble goal, but one that requires great wisdom, compassion, and foresight. We must strive to ensure that the benefits of these advancements are shared equitably, and that they are used to uplift and empower all of humanity, not just a select few. Ultimately, the journey towards understanding the true nature of our reality and our place within it is one that will require the collective efforts of scientists, philosophers, and visionaries from all walks of life. It is a journey that will test the limits of our knowledge, our creativity, and our resolve. But it is also a journey that holds the promise of unlocking the greatest mysteries of our existence and propelling us towards a future of unimaginable possibilities. As we stand on the precipice of this new frontier, let us approach it with a spirit of curiosity, humility, and determination. Let us be willing to question our assumptions, to embrace new ideas, and to work together towards a common goal of understanding and betterment. For it is only by harnessing the power of our collective wisdom and experiences that we may hope to navigate the complexities of our reality and secure a brighter future for ourselves and for generations to come. Whether we are living in a simulation or not, whether our reality is fundamentally digital or holographic, whether our essence can be teleported across space and time, one thing remains clear: the key to our survival and advancement lies in our ability to come together, to share our knowledge and experiences, and to work towards a common purpose. It is in this spirit of unity and collaboration that we may hope to unlock the full potential of our species and to chart a course towards a future of endless possibility. So let us embrace the ideas and concepts presented in this article, not as definitive answers, but as invitations to explore, to question, and to dream. Let us use them as a springboard for further inquiry and discovery, as a catalyst for the kind of bold and imaginative thinking that has always driven humanity forward. And let us do so with a sense of wonder, a sense of purpose, and a sense of hope for what the future may hold. For in the end, it is not the destination that matters most, but the journey itself. The endless pursuit of knowledge, the thrill of discovery, and the joy of coming together in service of something greater than ourselves. It is in this spirit that we embark upon this grand adventure, ready to face whatever challenges and opportunities lie ahead, and eager to see where the journey will take us next. Thank you for watching this. Denis Saklikov,